Right, we're on to waves now. Wave-L is used to send a signal to a satellite. What part of the electromagnetic spectrum does wave-L belong to? Well, you just got to know that satellites, microwaves, they pass through the atmosphere and they're used in mobile phones. What's the name given to the process that occurs when wave-L passes into the ionosphere? Well, if we look at wave-L, it seems to change direction there. So that, dead simply, is refraction. And then we're asked, wave M is reflected by the ionosphere. Draw the path of wave M until it reaches the receiver. And this is just an absolutely bog standard reflection diagram. And I'll draw that in a minute, but afterwards we'll draw a line, we'll have a look at this. Draw a line to show where the normal, where wave M meets the ionosphere, so we're drawing a normal as well. If you're going to draw the reflected ray, you need to get a rule at a straight line. And it says to the top of the receiver, not very straight, but make sure that it's a continuous line, so no gaps. And we're making the, sometimes in ray diagrams you need the arrow showing the direction, and the second mark we need the normal. Then the normal is always perpendicular to where, to the boundary of reflection. So if that was a mirror, we'd draw a normal at 90 degrees. And as you can see, the ray diagram's perfect because the angle of incidence is equal to the angle of reflection. This is a classic question about electromagnetic waves. Give two properties of all electromagnetic waves. In other words, what do they all share? Well, all electromagnetic waves are transverse, which means if the wave is travelling in that direction, the oscillations are at right angles to the direction that the energy is travelling in. So it's transverse, and I always do a little t with the right angle to help remember that. Again, something silly that sticks in your head. They're all transverse, and the second thing, they all travel at the speed of light. That's everything from low frequency, big wavelength radio waves, all the way through to gamma waves, which have a high frequency and very, very small wavelength. They all travel at the speed of light. And it might ask it, 300 million meters per second. In standard form, 3 times 10 to the power of 8 meters per second.